All right, guys, another day, more math. We're going to go through today. Today's actually going to be a new lesson. So we're going to go through, we're going to look at the last of the stuff I'm going to do with you guys for trig. We are skipping one or two things. They're just things that I don't want to do if I'm not physically there with you. So we're going to go through, we're going to solve a couple of right triangles today. We're going to look at word problems. The homework you guys are going to work on today is just going to be word problems. I think I gave you 6 and asked you guys to get it done by Monday. So we'll look at that at the end, okay? All right, so we're going to go ahead. We're going to jump back over to OneNote. Maybe. Hide that. And we're going to do a warm up first. So we're going to do what's called solving the right triangles. So I gave you guys a couple of right triangles and some information. We're going to find all the missing sides and angles. So when they ask you guys to solve a right triangle, what they're asking you guys to do is find all missing sides and angles. The first one, I gave you guys an angle measure and a side. So the first one, I know that angle C is 57 degrees, and I know that this side BC is 9. I need you guys to find the measure of angle A, the side length AB, and the side length AC. On the second one, I gave you guys different information, so we're going to have to handle it a little differently. I gave you 2 side lengths. So this side is 13 and that side is 4. And then I'm asking you guys to find the 2 angle measures and the missing side. So go ahead, work through those, skip forward, check the answers. If they're correct, you guys can move ahead. If not, listen to my explanations, okay? All right, so first one. If you guys are given an angle and a side, it's pretty easy to go back and define the measure of this other missing angle. I know the 3 in the triangle have to add to 180. I also know that because I got a right angle, that A and C have to add to 90. So if I want to go back and find the measure of angle A, all I have to do is take 90 minus the angle that I have, minus angle C. So 90 minus 57 is 33 degrees. So for the first one, the measure of angle A is going to be 33 degrees. If they give you an angle measure, go through and subtract from 90 to get the other one. Now, I'm not going to write the 33 in there. The reason I'm not going to do that is because the more information that I put on this triangle, the more confusing it gets when you guys are going through there, because you can choose which functions to use. Other thing that I actually forgot to do because we haven't had to do it yet, SOHCAHTOA. So SOHCAHTOA up there. Now when we go through and we start solving for side lengths, we're going to go ahead and use that. So I'm going to go ahead and try to find AB first. So I'm going to go ahead and put an X there. And I'm going to go through and I'm going to label my sides. So there's my hypotenuse. Based on my angle, that side is opposite, which makes my other one adjacent. So if I wanted to go through and define that side AB, I'm going to use, I've got opposite and adjacent. So if I look at my trig functions, that's tangent. So I want the tangent of 57 degrees to be equal to, and on the other side, we're going to set up that ratio. So the opposite side length is X, the adjacent is 9. You guys are going to remember from before that when the variable is on top, all you have to do is multiply. So we have to multiply both sides by 9 there. That one goes away. And I know that X is equal to 9 times the tangent of 57. Remember, always put that number in first, guys. If you go to your calculator and you put tangent of 57 times 9, if you don't close the parentheses off right, it's not going to work. So if you do 9 times the tangent of 57, this will give you the right answer. It's 13.858, so 13.86. If you do it this way and write tangent of 57 times 9, if you don't close the parentheses, it multiplies those two and it'll give you some weird answer, okay? It's not always negative, so make sure to watch out. That's wrong. Do not do that. So 13.86. So I know that this side AB is equal to 13.86. Again, guys, I'm not going to write it on there because once you start writing it on there, it gives me all these choices. Now, I could go through and I could use Pythagorean theorem to find that other side, but I'm actually just going to keep doing it with trig. I know the adjacent, and now I'm trying to find AC, which is my hypotenuse. So I'm going to stick a Y on that side and say I want to solve for that one. So if I'm working with A and H, that's going to be cosine up here. So exact same setup as the last one. Now I want the cosine of 57 to be equal to, set up the ratio. Now the adjacent goes on top, so that's your 9. And the hypotenuse goes on the bottom, which is Y. Now, when your variable's on the bottom, we're going to end up dividing. But the reason that happens is because we're going to multiply both sides by y here. Y times the cosine of 57 is equal to 9. And then I have to divide both sides by the cosine of 57. Remember, cosine of 57 is just a ratio, guys. So if I go back to my calculator, 9 divided by cosine of 57, 16.52. So AC, which is the hypotenuse there, y is equal to 16.52. And now we found every missing part of that triangle. Now I know all the different sides, all the different angles. So if they give you guys an angle and a side length, that's how you're going to go through and handle it. Subtract the one angle from 90, it'll give you the other one, and then use trig to go through and solve for the other two sides. Now the second one is going to be a little tricky because now we're going to have to go through, they didn't give us any angles. So we're going to go through, and I'm actually going to handle the side length a little differently on this one, and we'll look at it. Let's go through, and I'll zoom in over here. Let's go through and let's find the measure of angle x first, because that one's first on our list. So I'm looking for x, hypotenuse, opposite, adjacent. If I'm looking for an angle measure, I know that I'm going to use inverse trig. So when I'm trying to find the measure of angle x, I know the opposite side length and the adjacent. So that's going to be tangent. When you guys want an angle measure, you want the inverse. So the inverse tangent of 4 over 13, all we're doing is setting up that ratio, guys. Calculator, when you're doing inverses, you have to make sure to go to function. Tan inverse, main, 4 divided by 13, 17.1. And for these guys, I don't know how the homework's going to have you guys round, but I'm just going to have you guys round to the nearest degree. So let's call 17.1 17 degrees. So I know the measure of angle x is 17. Make sure, guys, to use common sense when you guys are going through this. The longest side is always opposite the longest angle. Shortest side is opposite the shortest angle. So 4 is a lot smaller than 13. That angle x should be pretty small. Now, I could use inverse trig again to go back and find z, but let's not make it harder than it needs to be. I know z and x have to add to 90. So z just has to be 90 minus 17, which is 73 degrees. So don't make that harder than it needs to be. When you guys can go back and just solve for that one, do it. Now for xz, I know that this is the hypotenuse. So over there, so I'm going to actually mark it C this time. And we could use trig, guys. I could put a 17-degree angle at x. I could put a 73 where z is. And I could go through and use one of these sides and solve. But then we start running into the thing where we got to decide which trig function to use. I'm just going to use Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. So when I'm going to go back and solve for xz, I've got 4 squared plus 13 squared equals c squared. Remember, c is always the hypotenuse. 16 plus 169 is c squared. 185 is c squared. And we want a square root. Oop, clear out of that one. Square root of 185 is 13.6. So that means our hypotenuse, or xz, is going to be 13.6. So solving right triangles, guys, all you guys are going to do is you're going to go through, find all the missing angles, all the missing sides. Use trig, use Pythagorean theorem, use the inverses, okay? All right, so we're going to go forward. There's actually none of those in the homework, but you will run into 1 or 2 of those. If I end up giving you guys any quizzes online, you'll run into those. If not, I guarantee you'll run into them Algebra 2. So you guys have to know how to be able to use trig to solve for missing sides, missing angles, and solve the triangles. All right, word problems. And just so you guys know, I'm trying to move pretty quick. That first video was 40 minutes, and I do not want them to be that long. So I'm going to move pretty quick through these. If you guys have to pause and move back or do any things like that, go ahead and do it, okay? So with trig, one of the main reasons we do trig is because we can use it to solve for sides of right triangles. And right triangles, it's really easy to set those up for real-world applications. Some of the vocab that comes up are angle of elevation and angle of depression. What I want you guys to remember is this. An angle of elevation, if you have like a guy standing here, and let's just say he's looking up at this big, pretty tree, and he's like, hey, I'm looking at the top of this tree. The angle of elevation is this angle right here. So it's the angle down in the corner. So it's the angle looking up when you guys are thinking about it that way. An angle of depression. So elevation is that one. An angle of depression, and excuse my drawing here. You guys know I can't draw at all, but let's just pretend like this is an air. Oh, God. Okay. So let's go ahead and pretend like that's an airplane. This is a spinner in the front. So it's one of those propellers. And then we got airplane wings. That's totally an airplane. You guys can totally see that, right? Yeah, that thing's flying. I don't know. That's weird. Okay. But let's just say the airplane was coming and this is a water tank. He's going to like drop water on a fire that's down here or something like that. An angle of depression looks down. Okay. So if we were going to think about that way, this angle right here is going to be the angle of depression. The good thing about angles of elevation, angle of depression, is these two lines here are parallel. So that means that this angle and this angle are alternate interior, so they're congruent. So I just drew all those stupid pictures and gave you guys all of that just to tell you guys that an angle of, oops, sorry, I hit the wrong button. Angle of elevation or angle of depression always ends up in the bottom corner. So some of these problems, when we're doing it, they'll already have diagrams drawn. If they've already got diagrams drawn, then you guys can use what's there. If we have to draw our own pictures and they talk about angle of elevation or angle of depression, they're going to end up in the bottom corner, okay? I'm going to go through and I'm going to do about 3 of these word problems with you guys. All the word problems are different. So the first 2 are fairly simple. The third one's a little tougher. If you guys get stuck on the homework ones, don't get frustrated. Send me a message. Come to office hours. We'll go through them, okay? All right, first one. I'm trying to move fast again, so sorry I'm running out of breath because I'm talking quickly. A tree that is 82 feet tall casts a shadow that is 23 feet long. What is the angle of elevation from the end of the shadow to the top of the tree? When you guys are doing word problems, we haven't talked about these in a while, but always go through and figure out the key information in the problem. I know here that my tree is 82 feet tall. I know that it casts a shadow that is 23 feet long. And one thing that I don't think you guys do enough of is you guys will find all those numbers. You guys don't always go through and figure out what you're trying to find. I want to know, what is the angle of elevation? So angle of elevation is what I'm trying to find. I showed you guys where that always ends up. So let's draw a picture. And guys, don't worry about what your pictures look like. They're all going to end up as triangles. So I've got a tree over here. And we've got colors. So now I'm going to waste some time and try to draw. I should have made the base of it brown, huh? So I've got a tree. You always got to put a little hole there, like, right? All right, I'll quit screwing around. So you've got the tree like that. It casts a shadow. So sun's going to be up over here. Sun's rays come down. The tree casts a shadow. Shadow is going to be along the ground. So its shadow is going to be here. It tells us that that shadow is 23 feet long. They also tell us the tree is 82 feet tall. So if I come through here, I know that the height from the base to the top is 82 feet. They ask us for the angle of elevation. So I know somebody's going to tell me my diagram isn't drawn to scale. 23 and 82 shouldn't look the same, but basically that's what we've got. The right angle is going to end up here. And they asked us for the angle of elevation. Angle of elevation always ends up in the bottom corner. So the angle of elevation is that angle right there. If they ask you guys to find an angle, that's inverse. So we've got to use the problem to distinguish the information, to set up these, or to draw the pictures, to figure out what we're doing. After that, it's exactly the same as what we were doing before. Every once in a while, the questions will be a little bit confusing, but you guys can figure them out. Hypotenuse, trying to find that angle, so that's opposite. That's adjacent. I don't have SOHCAHTOA written over here yet. Some old hippie caught another hippie tripping on acid. Okay. As you guys are going through, I've got O and A. So tangent is opposite over adjacent. So we are going to go through and use the inverse tangent. Tan inverse of 82 over 23. And then that just gets dumped into a calculator, guys. It's the exact same thing we were doing before. I know there's the picture there and that scares you guys because it's all in words, but it's exactly the same. 82 over 23. My allergies are killing me. 82 divided by, I know I've told you guys a few times that I was all paranoid about the coronavirus. I felt better yesterday because I went outside and I mowed. And as soon as I got done mowing, my nose was going crazy and everything. So I knew that it was allergies. 74.33. So that means that is a 74-degree angle. So the angle of elevation from the ground to the top of the tree is 74 degrees. Not so bad. Second one, the angle of depression from the top of a ski hill is 19 degrees. The slope of the hill is 2,500 feet long. How tall is the hill? So let's say that you're up here. Let's not draw your legs because you're actually on skis. So you got a couple of skis, you're getting ready to go down the hill, you got your sticks in your hand, and you can do that. So you're at the top of that ski hill. It's going down that way. It goes there. And we got that there. Again, don't make fun of my lines. Let me try to fix that one. Okay, so our right angle is going to be here. They tell you guys our angle of depression is 19 degrees. So I just want to remind you guys, what's really happening is that angle of depression. Looking down here is 19 degrees. Yes, he's looking down towards the bottom of the hill. But remember, these two are parallel. So that makes this 19 degrees. Regardless, angles of depression always end up in the bottom corner, okay? So angle of depression from the top of the ski hill is 19 degrees. The slope of the hill is 2,500 feet long. I want to know how tall is the hill, right? So you guys need to figure out where the slope is. And a lot of the time, kids have trouble figuring out where to put things when they're doing these problems. Try to put yourself in the scenario. Where's the slope? The slope is the part you're going down. You're trying to find height. Anytime you're trying to find height is straight off the ground, okay? So we're trying to find a side length, so that means we have to set up an equation, no inverse. There's my hypotenuse, opposite, adjacent. So if I've got O and H, SOHCAHTOA. So O and H is going to be sine. So we want the sine of 19 degrees to equal x over 2,500. When your variable is on top, you guys just get to multiply both sides. And 2,500 times the sine of 19 is going to be the height of that hill. So to make sure we're on the next one, I want 2,500 times the sine of 19, 813.92 feet. My phone just went crazy. Work that really quick. Sorry, a bunch of emails, and it's trying to tell me I already took a bunch of steps. Sorry. So the height is 813 feet. Let's do one more, guys. Thank you guys for sticking with me. This one came right out of your textbook, so I wanted to go ahead and do one because you might have some pictures like this in the 6 homework problems I gave you. For a reverse bungee ride, Reagan stands halfway between 2 vertical posts. So we've got him here. 2 bungee cords extend to the top of the post. So your bungee cords are going to be these guys. Well, their bungee cords are right here, actually. They say to Reagan's waist at a height 1 meter above the ground. And they want to know how tall are the vertical posts. So this 1 meter off the ground, guys, I'm going to go ahead and leave this until the end because we're going to need this. They're telling us again that we've got that 70-degree angle. So they show us the 70-degree angle here. They want us to find this height. So I'm trying to draw all over this picture. They want us to find this height X. And they told us that there's 8 meters in between. So if we go to set up this triangle, and I'm going to redraw it in a second, we know this distance right there as well. So let's redraw this picture. And if you guys get confused, that's what I want you to do. If the pictures have too much going on, a lot of the time when there's all this extra stuff and colors and all that, it gets me. So I just like to redraw a basic triangle. I know that this is a right angle. I'm going to remember that this is 1 meter off the ground. So we're going to talk about that later. I know this is a 70-degree angle. And then this one was actually a little tricky. If there's 8 meters, so I know this is 8. He's halfway between the two of those. So I know that the bottom side here has to be 4 feet. Okay. We want to find height, so that's X. Once you guys get there, it's exactly the same as everything else. We're trying to find a side length. So this is going to be an equation. Hypotenuse, opposite, adjacent. O and A is tangent. Tangent of 70 degrees. Set up the ratio on the other side, X over 4. When the number is on the bottom, it's easier for us. We just get to multiply. So X is equal to 4 times the tangent of 70 degrees. Calculator. 4 times tangent of 70. 10.989. So let's call that 10.99. They might want it to be 11. So let's come back over here. So I know this height is 10.99. They wanted to know how tall are the vertical posts. You guys got to be careful here. They told us that we were measuring from 1 meter off the ground, right? So this is 10.99. The ground is really down here. So we have to add that 1 meter. So the 10.99 plus the 1 meter off the ground is 11.99. I'm guessing the book wants you to tell them that's exactly 12 meters. So guys, that basically is trig. We skipped something called the law of sines and the law of cosines. In all honesty, if we would have been in school, we would have spent more time solving right triangles and going through and practicing and doing that kind of stuff. Next year, it is really, really important that when you guys run into trig, that you guys can go through. If they give you a right triangle, your sine, cosine, and tangent, you guys can solve for sides and solve for angles pretty easily. You guys, they'll give you 3 more trig functions next year. It's going to be secant, cosecant, and cotangent. They're just going to be different ratios of side lengths, and you guys are going to do a lot of the same stuff with them. One thing that we missed at the beginning of the year, and I just remembered that I wanted to throw this in there. All year I've been telling you guys that I wanted you guys I was excited to play Getting Tricky with it for you. So I'm going to go ahead and I'm going to play it right now. It's screen recording. So this is one of the favorite things that I get to do with you guys through the years. We get to watch this video and I get to tell you guys all about when Will Smith was a rapper. Hold on one second. This is actually some teachers. They're from Ohio. They did a bunch of videos like this a few years ago. A big thing with teaching was, look at that, it's already at the top, was making videos and songs and trying to relate to kids that way. So a bunch of teachers in Ohio with their students went through and did this. So I'm going to go ahead and I'm going to play this and then I'm going to end the video after that. So assignment is on Pearson, just so you guys know. If you guys go into Pearson Realize here, go to your classes. 4th period is a smaller class, but so if we go to assignments here, you guys got to get working. The 8.5 I just posted. Good job, 19 of you guys got the one from yesterday done. So really good job. I appreciate all of you guys working. I know there's not that many of you showing is done here, but those of you guys that are sticking with me, I appreciate you. Okay. All right. So I'm going to play this and this will be the end for today.
Good morning, guys. I am so excited because we are finally going to start our unit on trigonometry this morning. Miles.
Is there any way we can make this more fun or something?
On your mark, ready, set, let's go. Trigonometry, bro, I know you know. I go psycho when I see a triangle. Just can't sit, gotta get tricky with it. Oh, that's it, 3 angles, 3 sides. T-R-I-G, all up in my eye. Soka, Toa, will tell you where to go. You just gotta know about H and O. Everybody looking at a glance at the box. The H while P is sitting across. Theta, theta, is that the eta, eta? That's on it, for the look, I don't mark it. Beside you ain't touching, it's the OPP. Making it tricky, we want you to see. Yo, what's that last side you say? Ha ha! It's gotta be the ADJ. Get tricky with it. Get tricky with it. Get tricky with it. Get tricky with it. What? You wanna solve with the trig? Watch your step, you might fall trying to work this gate. Soka, soka, toa. In the middle of the problem, don't know which one, huh? You gotta know which angles and sides that are missing and given in the problem. They're the guides. You can come with me, all these problems I've tried. Heard it's hard? Well then somebody lied. It's Soka Toa, helps you to study. So you know when to use each one. If you got the O and HYP, so let's you know such a way to go. Let's say now you got the HYP and the ADJ, then cosine's the way, yes, y'all. But there's one more. You got the legs?
Well, hypotenuse.
That makes it tan. Getting tricky with it. Getting tricky with it. Getting tricky with it. Getting tricky with it. Roll with me right now. If you need a side, you gotta know 2 things. Okay, let's ride. You need an angle and one of the sides. Issue is, where does X reside? You see it up high, that's how you know to multiply. So easy, you get it on your own first try. Trig to the maximum, I'll be axing them. How about the one time you gotta use division? Only if X is down below. X and the angle will switch, you know. Last case, it's angle finding time. So let's get it, trust. The data is the goal, get it alone. Calculators will know when I say go. Take the inverse of the numbers on the right, hit equals and show it off. Now you got it, get tricky with it. Get tricky with it.